I'm on a whole new
Hello guys, and today I want to talk to you about the scientific method. Now, the scientific method is the only scientific way accepted to back up a theory or idea. This is the method on which all research projects should be based. The scientific method is a model or guide used to solve problems, and today I'm going to talk to you about some of the components that make up that scientific method. Now, for the scientific method, there are 6 steps that are involved that you will need to know about. They include observation, problem or question, hypothesis, experiment, result, and conclusion. Now, the first step in the scientific method is observation. It usually starts with somebody noticing something. You observe something, you begin gathering information in the material world, and you use your world-class senses or machines, which are basically extensions of those senses, to gather this information. So this may include anything from noticing colors to the way something feels or smells, or the number in some cases. And we're going to talk about those types of observations. Now, there are 2 types of observations that you need to know about. They include qualitative observation and quantitative observation. The word qualitative observation comes from the word quality, and in this case it refers to observations of something using your 5 senses. This includes smell, touch, sight, any of those things. And an example would be if you were looking at the tree, the leaves on the tree are green. A quantitative observation, however, deals with observations that deal with numbers. They deal specifically with numbers. And in this case, an example would be if a tree was noticed and the tree had 4 leaves on the tree. So that is the distinction. Quantitative observation comes from the word quantity, which refers to the number. So think about that as you go through. Now, the next step is after you've gathered your information, you begin thinking of a problem, or you notice a problem, if you will. In essence, the problem is the question that you want to find the answer to. And to find the answer to that question, you then come up with an hypothesis. In this case, a hypothesis is used to predict what you think the answer to your question might be. Now, all hypotheses must be testable, and they represent an educated guess of what you think will happen. In some cases, you'll start your sentence by saying, if I do this, then something should happen. In that case, that is your hypothesis because you expect that something may happen, and it may not be right or it may work, but you will need to test it. And in order to test it, you move to the next step, and that is the experiment phase. In the experiment step, you figure out a way to test whether your hypothesis is correct. The outcome must be measurable, meaning there should be some type of number that goes with that. The experiment needs to be repeated at least 3 times because you don't want your results to be a fluke. You want to confirm that what you're finding is indeed the case. And so that is why it's important that when you do your experiment, you try to repeat that experiment to make sure that it is going the way that you want and you are getting consistent results. Now, after you've done your experiment is the results. Now, this is where you record your data, you analyze the stuff, and you must record the stuff after each trial. Even if the experiment doesn't go the way you want it to go, you definitely want to report what you see because that is important in your observations and making sure that your scientific method holds true for your project or any test. Now, after you've gathered your results, you then want to state your conclusion. In this case, your conclusion is used to confirm whether your hypothesis was right or wrong. Here, you'll also take the time to explain why you got those results or if they go with your information and why they go with what you hypothesize. In this case, this is where you would tell what you've learned from your experiment. And that's why it's a conclusion, because it concludes everything. And so those are the steps that matter, but there are some additional things that we must consider when we're doing an experiment. One of the things that tends to happen in some cases, and it's definitely frowned upon, is the idea of a bias. And bias reflects a personal opinion instead of recording the actual results. Now, when you are doing an experiment and you expect something to be a certain way and it does something different, you are supposed to write down what the different thing is that occurs and not supposed to write down what you think should happen. Because if you write down what you think should happen, or you think that the results meant something else as opposed to what you got, then that's creating a bias. And bias usually creates an unfair scenario for your scientific project or science test. Now, forming a bias can also lead to errors in your results. They are not part of the scientific method. So anytime you're running a test, you definitely want to stay away from a bias. Now, the other thing that you want to consider are these things called variables. Now, when you're doing an experiment, you're always testing this thing called variables, and they are different factors that change in an experiment. If you wanted to design an experiment to test which brand of gum has the most amount of sugar in it, you would have to test different types of gum. Those different types of gums would represent your variables. Now, there are also different kinds of variables. There's a constant variable, and that's the thing in the experiment that stays the same, because you always want to have at least one thing that's the safe, surefire variable that doesn't change. If you want to taste different drinks or different sodas and you want to see which one tastes the best, a constant variable might be something like giving everybody water, because everybody expects that water tastes the same for the most part. And if you try different soda brands, you would get different experiments. So in that case, constant variable would stay the same. Another constant variable would be if you use the same amount of soda for each experiment. So in that case, they can either reflect a lot of things, but constant variables keep everything together. Now, the other variable out there is called the independent variable. This is the I change variable. This is the thing that when you're conducting an experiment, you can control it. You can change what you want to change in your variable. If I want to design an experiment to determine which jacket keeps me the warmest, then I change the different types of jacket material that I use. And that is what my independent variable is. It's the factor that you, the experimenter, changes. Now, as a result of you changing those independent variables, you get something called the dependent variable. Hence, the word dependent means depends on the independent variable in this case, and it changes your results based on your independent variable. If you decide to test different types of jackets, if you use a wool jacket and use a cotton jacket and you decide to use a paper plate jacket, those variables are going to determine how warm you get. In that case, the dependent variable would be the warmth of the jacket. Hopefully you wouldn't think that a paper plate jacket would keep you warm, or else you'd be creating a bias. But in essence, the dependent variable depends on the independent variable.